Okay, so the title of today's lesson is Solving Polynomial Equations, but in order to do that, we're going to need to be good at factoring, because factoring, when it's possible, is the best way to solve. It's not always possible, but when it is, it's great. And in this lesson, I'm going to show you some new ways, factoring techniques that you probably have never seen before. So let's talk about those first. My first example involves factoring either the sum or the difference of two perfect cube terms. And what I mean by that is these two terms have perfect cube roots. So some perfect cube root numbers are, for example, 8. Because the number 2 multiplied times itself 3 times, 2 times 2 times 2 is 8. So the cube root of 8 is 2. 27 is another perfect cube root number. The cube root of 27 is 3. 64, the cube root of 64 is 4. Whenever these two terms have perfect cube roots, then we have an opportunity to factor them, which makes these equations a lot easier to solve. So these two factoring methods that I've provided for you, you're going to use those quite a bit in tonight's lesson. So hopefully you'll have a chance to practice them enough to where they become very familiar. All right, so let's take a look at an example. My example letter A. First of all, my green statement is always true. Anytime you're factoring, you should always make it a habit to check for a GCF first. So I'm looking at my problem letter A and I do not see a GCF. So I'm going to go up to this factoring pattern, or you might call it a definition, that shows the difference between two perfect cube root numbers or terms. Each of these have perfect cube roots and they're being subtracted. So let me show you how the factoring works. This A and B in the factoring pattern represent the cube roots of each of the terms. So in this binomial, I'm going to write the cube root of x cubed, which is x. Since it's subtraction here, it will be subtraction in the factoring in this binomial. And now I'm going to do the cube root of the second term, and I got to do the cube root of both of these. The cube root of 8 is 2, and the cube root of y cubed is y. So what I've done so far is the equivalent of this part of the pattern. I've done the A minus B. The rest of the factoring is based on those two terms. This tells you exactly how to get the rest of the factoring. All right, it's going to be a trinomial. This tells me to take the first of these two terms and square it. So my first term in this problem is x. I'll raise it to the second power. The next sign, according to the factoring, is plus. This tells me to multiply the two terms that I came up with together. These two cube roots, I'm going to multiply them together. Now this is tricky for some people because the tendency is to treat this as x times negative 2y and get a negative result. But the factoring pattern has to be exactly like this. This sign has to be plus. So I'm just going to multiply x times 2y and I get 2xy. The next sign is plus. And now I take the second of the two terms called b and I square it, and that's 4y squared. And that's it. That is the factoring for letter A, the difference between two perfect cubes. Now let's look at a sum of two cubes example. It's very similar, but notice the sign change. I still start off with the cube roots. The cube root of 64 is 4, and the cube root of a cubed is a. Whatever this sign is in the problem will also be the sign in the binomial. And now I do the cube root of 1, which is just 1. So now I'm following this top example that shows the sum of two cubes. I found A and B, And now I'm going to use A and B to come up with this other trinomial factor. Square the first of the two. So I'm going to square 4A, 16A squared. The next sign in the factoring should be minus. I'm going to multiply these together, 4A. Next sign should be plus. And now I'm going to square the last, or the second of these two terms. 1 squared is just 1. Okay, so there's some tricky sign things here that you can overcome with practice. Just like everything else, or most everything else that we do in this class, the more you practice it, the better you're going to get. So please be careful and notice these little sign, they're tricky. So be careful when you write the factoring. Okay, letter C. What should I always check for first when factoring? GCF. You need to train yourself. Always look for a GCF first. Is there a GCF between the numbers 5 and 320? What would that be? What number, the largest number that goes into 5 and 320? 5, okay? Now let's look for a common variable. Is there a common variable between these two terms? Looks like they each have y in them. So y is a common variable, y to the first. Okay, so I do have a factor. The greatest common factor is 5y. Josh, what would the other factor be after I factor out 5y? What would go in the parentheses?
Y to the third.
Good?
Minus.
It's kind of big. You know what 320 divided by 5 is? 64? Good?
64 is
Nice. Okay, so we factored out GCF. Now look in the parentheses, and that should look familiar. Just going back to our previous slide, that represents the difference between two perfect cubes. So we're going to follow this factoring procedure. Let's see, August, as far as the binomial part of the factoring, can you tell me what these two terms, the cube roots of each? Okay, what sign? Good? Good? Good, very good. And then Kyle, he's given us a really good start based on those two terms. What's the trinomial factor going to look like?
Y squared plus,
It's okay if you need to look.
4y
Good?
plus 16z squared.
Very good. All right, looks like we have done all the factoring that we can do, so that would be my answer for letter C. But the big heads up here is always look for GCF first when factoring. Kate, letter D, look for GCF. Do you see a GCF? No GCF, okay. Well, my next possibility would be, notice these two cubes. Can I factor this as the sum of two perfect cubes? Do each of these terms have perfect cube roots? No, 5 doesn't have a perfect cube root. So this isn't truly the sum of two cubes because 5 doesn't qualify. So the directions say factor if possible. Well, this is not possible, and it says if it's not possible, then you're going to write the word prime. So letter D cannot be factored. There is no GCF. There is no other factoring opportunity, possibility. So that is considered to be prime. Okay, letter E. BJ, is there GCF? Does 4 go into 54? Nope. They're both even, so definitely 2, all right. And then what about a variable? Does the GCF contain a variable? Very good. Okay, Trent, can you tell me after factoring out 2x, what would go in the parentheses?
X cubed.
What about a number in front of x cubed? 16 divided by 2. Good. Okay, plus, and then what?
54y cubed.
Well, 54 divided by 2. You got a calculator? 27, and then what was the other part you said?
Y cubed.
Very good. All right. So Samantha, can we do any more factoring? Is this the sum of 2 cubes? Does this qualify as 2 terms that have perfect cube roots being added together so that we could use this factoring? It does? Okay. So can you help me factor it? What sign after 2x? Plus, and then cube root of 3y. All right, that's the binomial. And now what's the trinomial? You got to square this whole 4x squared. Good. The sign. What sign would go here? 6xy. And then what sign? Good. And we're done. So that is the complete factoring for letter E. Okay. Example 2. This is factoring that you've probably, I don't know if you've ever done this before. It's probably new for most of you. It's called factoring by grouping. We have 6 terms, and to get us started, I've chosen some pretty easy ones. They set up real nicely. I want to break these up into 2 groups of 3, and within each group of 3, there's a GCF. So Micah, in this left group of 3, what would you say is the GCF? 2y. All right, and Micah, go ahead and factor out 2y in that left group of 3.
That's going to be 3a plus 2b minus c.
Good. All right, very good. So Jackson, give me I'm going to bring down this plus sign that's shown here, and give me, Jackson, the GCF out of the second group of 3. And what would the other factor be, Jackson?
It'd be 3a plus 2b minus c.
Wow, interesting. Do you notice that the 2 parentheses match? Exactly, same terms, same signs. That's a great sign for you, no pun intended. That is a great feeling. If you notice that these 2 groups, these 2 parentheses match, you've done the right thing. Now here's how we're going to write our answer. Think of this parentheses as a GCF. So part of my answer will be the part that you see in parentheses that matches. The other factor will be everything not in parentheses put together. So I have the parentheses that should match. If they don't match, then you've done something wrong. You need to keep working. And then my other factor will be just collect the other terms that are not in parentheses. And this is the final answer. Okay, let me go to Landon, first group of 3, GCF. Okay, and what would the result of factoring out x be?
A squared plus 3a plus 2.
Very good. Okay, now the next sign is minus, so I'm just going to bring that sign down. And then Luke, can you help me out with the second group of 3? What is the GCF?
1.
1 won't count as a GCF. Do you see something in common with these 3?
So it'd be the same as the first one.
Do you see, if you look at these 3 terms, and it might be easier to see on your paper, they all have the same variable. What is it? Don't they all have y? Okay, and so y is the GCF. So Kate, factor y out of this second group of 3, and what do you have? Now be careful because you're technically dividing by negative y.
Okay.
So negative y divided into positive a squared y.
Negative a squared? Wait, no. A squared plus
I'm sorry, I said positive, I meant negative.
a squared plus 3a plus 2.
Okay, and we are good because we have the same group in parentheses, they match. And so to finish off the answer, I've got a squared plus 3a plus 2 as one of my factors. And then the other factor will be all the terms that are not currently in a group. We put them together. Good job. Questions? Okay, letter C, a little more challenging because it's not set up just perfectly to where we can group the first 3 and the last 3. We're going to have to do a little thinking here. We're going to have to do a little rearranging so that my first 3 terms do have a GCF and my second 3 terms have a different GCF. I want you to look over it, maybe looking at your paper will be a little easier. Can you see something in common with 3 different terms? Is there something that stands out? I heard somebody say A. A squared? Okay, so 3 of the terms have A squared and the other 3 have B squared. So I'm going to break them up. I'm going to rearrange them so that I put the A squares together. So there's the A squares, and then the other 3 have B squared. And now we're back to doing what we did before. You can just think of the first 3, factor out that A squared. And Will, when I factor out A squared in the first 3, what's left?
Minus 3h plus 6f.
Okay, and I'm going to bring down minus, and we already know that B squared is the GCF for the second group. And so what do I get here? Campbell?
6f plus g minus 3h.
Okay, now I wanted to do this because some people might think, well, that's not the same. You know, we said earlier, if we get the same thing in the 2 parentheses, then we've done the right thing. Well, this really is the same thing. The terms are just arranged differently. Just double check your signs. Positive G, negative 3H, negative 3H, positive 6F, positive. So when I write my final answer, I'm going to put these alphabetically. That's the proper way to write polynomials like this that have different variables. So I'm going to put F, then G, and then H, and then I'm going to put my other 2 terms that were not previously in a group, now they are. Now be careful here because I still have more factoring to do, and you learned this in Algebra 1. One of these can be factored more. This one is the difference between two squares. So I'm gonna leave this for just a second, and I'm gonna come back. Can somebody tell me how to factor this guy? Two perfect squares being subtracted. Josh.
Is it x plus 6 and x minus 6?
Nice. Remember that? Well, that's exactly what's being represented here. So Micah, give me the final factoring. I'm going to write this down again. How would you factor a squared minus b squared?
I have no clue.
Okay, just like Josh did with this.
A plus b and a minus b.
There you go. So heads up. Be on the lookout for the difference between two squares, because you can factor those more. A lot of people lose points because they don't factor all that can be factored. Okay, now we're down to the good stuff. We're skipping this. Why do we factor? It's to help us solve. You technically haven't ever factored these quartic, that means fourth degree trinomials, but let me give you something that you have done that's very similar. Do you see the similarity between what I wrote here in green and what's in red? Okay. Remember when we used to factor these back when math was easy, life was good, back in Algebra 1? Anybody want to volunteer to factor this green quadratic trinomial? Factors of -6 that add up to +1. Anybody want to take a stab at it? Kyle, what do you think? Any factors of -6 that add up to +1? +3, -2. Remember that? Everybody remember that? Give me some feedback. Okay. If you remember how to do this, well, I'm going to come back over here. I'm going to show you how great this is. You're going to love this. You might think, wow, that's fourth degree. How in the world? Well, just remember what you did here. You ready for this? You ready? Boom. You got it. That's all there is to it. Now, I haven't solved anything, but the factoring leads me to the solution. How many solutions am I looking for? 4. Yeah, whatever the degree of the polynomial is, in this case it's fourth degree, that's how many solutions I should end up with. And here's how I'll get them. Each of these factors, just think of them as two separate equations equal to 0. And solve each one of the equations. Okay, I'm going to solve this left one. X squared plus 3 equals 0. And then I'll just make a little line here and we can solve the other one right beside it. So my first move would be to subtract 3. And then I got to do the square root of both sides. I remember my teacher told me years and years ago, anytime I do the square root of both sides of an equation, I have to do plus minus. And if I'm doing the square root of a negative number, that means I have to use the number I. So how many solutions is this altogether right here? 2. Positive I root 3 and negative I root 3. So I'm halfway to my final answer. So I jump over here and I solve this and I'll have the other two. X squared equals 2. X is equal to plus minus root 2. How many solutions are contained here? 2. So if you forget plus minus, you're only going to give me half of the answer. I'm only going to give you half the points. All right, letter B. Can we factor this? Are there factors of -5 that add up to +6? Any ideas? Factors of -5 that add up to +6? Okay. No, there are no factors of -5 that add up to +6. So, therefore, at this point, the only way that you have, now that's going to change in just a little while, but at this point, the only way we could solve this is by factoring. So if you were to run into a problem like this tonight and it doesn't factor, then you're just going to say not possible. Now I hope I've weeded those out for you, but just in case, I just wanted to give you a heads up. I've tried, I think I've selected problems that all should be factorable, but in the event that I skipped one, if you cannot factor, then you're just going to say not possible. And you're going to move on. Okay, let me get to Trent on letter C. Going back to what we talked about at the very beginning of the lesson, the sum of two cubes. That fits that description. These are both cube root terms. So if you want to look back at that first slide or second slide to help you remember, can you tell me how to factor this? It's the a cubed plus b cubed pattern. I find the cube roots first. So what's the cube root of x cubed?
X plus 8.
Close. It's the cube root of 8. A number multiplied 3 times to equal 8. Cube root of 8 is 2. Okay, now that you have those two, can you give me the rest of the factoring? Good. And what's the next sign? Well, it's just these two multiplied together. Minus 2x. So you square the first, you multiply them together, and then last term. You square this second term. Okay, how many solutions am I looking for? 3. And they come from the factoring. Well, one of my solutions is pretty easy to see. If I let x plus 2 equal 0 and solve, I get x is -2. 1 down, 2 to go. Josh, can I factor x squared minus 2x plus 4? Are there factors of 4 that add up to -2? Well, that wouldn't give me -2 in the middle. So are there any factors of +4 that add up to -2? Okay. Since factoring isn't possible and this is a quadratic, then I'm going to have to rely on other methods, like quadratic formula, completing the square. Which would you prefer? I'm going to do the quadratic formula. So we've got one of our solutions. Here's how we'll find the other two. Quadratic formula, the opposite of b, plus minus the square root of b squared minus 4ac all over 2a. And now I'll just work on simplifying this. If I do something that you don't quite understand, please let me know. Don't just take my word for it. I'm just working down this way. Any questions so far? Now I can reduce because these numbers, obviously all of these are divisible by 2, so I shouldn't ever leave an answer if reducing is possible, I shouldn't leave it in unreduced form. So dividing by 2 into all of these numbers not under the radical gives me this. Now, how many solutions does this represent? 2. 1 plus I root 3 is a solution. 1 minus I root 3 is a solution to go along with negative 2. So that's my final answer. Any questions? All right, letter D. Think like you did when these were quadratic, except the only difference, we looked at this earlier, instead of having both of these being just x, they're going to be x squared. Samantha, are there factors of negative 10 that add up to negative 3? Two numbers that multiply to give you negative 10. So which one would be negative? One of them will have to be negative. Which one? To make negative 3. So it's either this, all right. Okay. All right, and so now that I've got the factoring, I let each factor equal 0 and solve. So Campbell, help me out. Whoa, sorry about that. Help me out with this left equation. Okay, and what are my two solutions? Good. By the way, leave your answers tonight in simplified radical form. Do not come in tomorrow and say plus minus 2.2. Don't use your calculator. Simplified radical form only. Landon, what about the other two solutions? We got two of them. What are the other two? How are we going to solve for x here? Okay. I times the square root of 2. Very good. Questions? Does it make sense? I'm going to give you a chance to practice it, so now you can perfect these skills. If you have any questions, send me an email.